So, okay, I've got to take a video. And one of those days, taking a video makes me feel better. So, we're going to try to feel better here. I got this in the mail today. Um, it's what they call agate, and I think it's actually silicon carbide. But there's some black diamond inside of it. They form together. The diamond forms first, and then the silicon carbide starts precipitating out in the carbon, right? The silicon is attracted to the carbon, and carbon has like the highest melting point of any mineral, and so it precipitates out first, and diamonds are clear, right? And this is actually clear inside of there. Um, and I don't have another light handy, but I might be able to actually shine a light on this side and see it on this side. Um, we'll try that on another video, but I just wanted to look at this one, see what we've got here. Got hemp seed oil all over it already. Everything's got hemp seed oil on it around here. Isn't that something, huh? So you'll notice that these little round thing gummies are kind of in an orderly pattern and like rows and columns and stuff. Um, and that's because of the crystal structure. Um, and the silicon is one of the few minerals that could possibly combine with the carbon and share the same kind of bonding. In a diamond, it's all just carbon, and it has covalent bonds. This is also 10 on the Mohs scale of hardness, like a diamond. You can't scratch it with with a known diamond. And you can't scratch any part of it. That is this diamond part and the silicon part are the same hardness. And it's mixed together because they can share, I think, a covalent bond because they both have the same, they're both in the same column of the periodic table, and they're semi-metals. That is, they have 4 electrons in the outer valence orbit, the orbit that allows them those electrons to bind with other things, and that's how chemistry works. The outer valence orbit is critical to how they bond with each other. So anyway, these two elements both have 4 electrons in the outer valence orbit, and I think that's why they are attracted to each other and why they form possibly covalent bonds. Covalent bonds are supposed to be just in same element situations like carbon in a diamond. But I think that would be the only explanation for why it's so hard. And you can't melt it. I've tried with a blowtorch, and with a plasma torch at 3,000 degrees Celsius, and they are impervious to anything I have been able to come up with. So, anyway, I'm having a ball finally. This is a beautiful little sphere. Going in my collection because it looks like kind of like a bear or maybe a black cat, or you got to use your imagination and squint a little bit, but hey. I have a vivid imagination. Peace, y'all.